Hi everyone, my name is Steve. Today we're going to talk about LeetCode problem 1535. Find the winner of an array game. Let's take a look at the problem first. It's giving an integer array A of distinct integers and an integer k. How the game will be played is like between the first two elements of the array. That means array 0 at index 0 and at index 1. In each round of the game, we compare the first and the second elements. The larger integer wins and remains at the first position, and the smaller integer moves toward the end of the array. The game ends when an integer wins k consecutive rounds. Return the integer which will win the game. This is the problem, and it's guaranteed that there will be a winner of the game. So let's just take a look at one example. It's given this array 2, 1, 3, 5, 4, 6, 7, and the k is 2, which means we need to find a winner that wins this comparison game twice consecutively. Let's see. The first round is this given original input array 2, 1. So the first two elements are 2 and 1. The winner is 2, and 1 is moved towards the end. Everything else shifted towards the right. So 3, 5, 4, 6, 7. 3, 5, 4, 6, 7 are shifted towards the right because 1 has been moved towards the right. And then 2 wins once. And then we keep playing the game, which is the first two elements are going to compare 2 and 3. So 3 wins. So 3 moved towards the front position and 2 is shifted towards the back. Everything else shifted towards the left. So 3 wins once. We continue playing this game for the third time. It's 3 and 5 are the two front elements. They are going to compare. 5 is the winner, right? So 5 wins the first time. And then we have 5 and 4. These two front elements are going to compare. Again, 5 is the winner. So 5 wins the second time. And the required times to win is k. K is 2. So that's why we return 5 in this test case. We can go through a few more test cases. For example, this one, 3, 2, 1, k equals 10. That means we need to find k times, which is 10 times, such a winner, such an integer in this given input array that wins consecutively 10 times. There's a total only 3 integers in here. So what we have is, of course, it's going to repeat itself. But in this case, pay attention, there's only a total of 3 integers, which is less than the number of k. So what are we going to do? We're just going to return the largest one, which is 3. And in fact, that is the case because, like say, we just keep comparing. In this case, 3 and 2 compare, so 2 moves towards the right, and next one is 1 in the second position. And then we compare the second time, 3 compare with 1. It's still 3 is the winner, so 3 wins the second time, right? Then 2 is back in the second position again. We continue to compare. You see, this is a cycle. We keep comparing 3 with the remaining of this array, and 3 is always the winner, so 3 will continue to win many times k specifies. But do we really need to go through all of that times? No, we don't. Right? That's just repetitive. It's repeating itself. So we can just cut it short. We'll just return the max number in this given array if the total number of distinct integers is smaller than k times. Now let's take a look at example 3. We're given this. This one is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 elements, and 8 is bigger than 7. So let's see. We'll just follow the rules to compare the first two elements, 1 and 9. 1 will be shifted towards the end, 9 stands in the first place. And now looking at this array, we know 9 is the biggest element in this array, so 9 will always hold the first position. Everything else, the remaining elements, they will just keep shuffling, right? So 9 will win 7 consecutive times in a row, so we'll return 9 in the end. Now let's take a look at example 4. We're given this array. K is what? K is like, say, this is 30, okay, 30, okay. K is 1 billion. So which number can win 1 billion consecutive times? It's guaranteed to be the max number in this given array. Since this problem, it says it's guaranteed there there will be a winner of the game. So in this case, it's very safe that we just return the max number. The k is like so many orders bigger than the total length, the total number of distinct integers in the given array. The only possible solution in this case must be the max number of this array. All right, that's the first thing that we need to pay attention to, which is the case when k is greater than or much greater than the total number of distinct elements in this given array, then we're guaranteed to return the max number in this given array. What about the second thing that we need to pay attention to? That is when k is smaller than the total number of distinct integers in this given array. In that case, what can we do? We can just track the biggest number that wins so far when we have a one pointer to move from the left towards the right. Every time when we encounter a bigger element than the current one, we can just mark this winTimes to be 1 and say, if this current element is always greater than the next few elements that we are comparing against, then that means this element is the one that will keep standing in the front row. Then we can just keep incrementing the winTimes. And whenever the winTimes is greater than or equal to k, we can simply return the current element, which is the element that is standing in the front. The trick here is that we don't really need to imitate what the problem is describing. See, you don't need to really increment an array list in Java or a doubly linked list that you can move the one element that is the loser after comparing with the other element in the first two elements and move that one towards the end of the array or the queue, and then you keep doing this shifting. That is really not necessary to do the simulation. What we can do is very simple. We can just use constant extra memory, and this is a one pass. Now let me put this idea into the actual code. Let's take a look. So first, we call this one, we'll initialize two variables. One is called winner. We'll just use the very first variable in the given original input array to be our winner. It can change, of course. In many cases, it's going to change, but that's totally fine. We'll have another variable called winTimes. winTimes. First, this one, the first element, we haven't compared it with anyone else, so winTimes is going to be 0. Now let's have one pointer, have a for loop to go through this entire given array, and we do the comparison. We play the game. It says we play the array game. We'll start from the first element. We'll start from the second element, which is index equals to 1, and then array length I++. So we do the comparison. If the current one that we're iterating on is greater than the winner, that means this is the new winner. So we'll use this one as the winner. We'll override the current winner value with this one. And winTimes is going to be 1 because we have finished one comparison. We played the game once with the current winner. So winTimes is going to be 1. Otherwise, what that means is the current winner, regardless which one that is still the winner. So in that case, what we're going to do is that we'll increase winTimes by 1. That is what it means. And every time after we do this, we want to check if winTimes is already greater than or equal to k. If that is the case, we can just return winner. We can just return winner. Boom, because we have found a number, a winner that has won consecutively k times, at least k times already. And in the end, we can just return winner. This one will help us with the first case that we just discussed when k is much larger than the number of distinct elements in the given array. Then it must be the max number. In that case, we can simply return the winner in this case. Now, let's hit submit and see. All right, accepted. The time complexity of this algorithm to solve this problem is simply O(n). We only need to iterate through this given array only once. You see, there's only one for loop. All of these operations are constant. Space complexity is O(1). We haven't used any extra memory. All of these just a couple constant variables. It takes constant time, so that's why it's O(1). That's about this problem. I hope it helped people understand this. If that is the case, just do me a favor. Please smash the like button. That's going to help a lot with the YouTube algorithm and help me out tremendously. I really appreciate it. And I have accumulated quite a few LeetCode tutorials or videos or algorithm or data structures in my playlist. So feel free to check it out. Hopefully I'll see you guys in just a few short seconds. And don't forget to subscribe to my channel as we continue to go through a lot of interesting LeetCode problems or algorithm or data structure problems. All right, I'll see you guys in just a few short seconds. Thank you very much.